from Truemaths, and in this video we are going to solve question number 4 of exercise 12.3. The question says, find the area of the shaded region where a circular arc of radius 6 cm has been drawn with vertex O of an equilateral triangle OAB of side 12 cm as center. So here I have to find the area of the shaded region, and the complete figure is a shaded region here. So I have to find the complete area of this figure. Okay, there is no unshaded figure. The complete figure is shaded here. Okay. Then after that, here this is an equilateral triangle with side 12 cm, and this is a circle with center O. So if you want to find out the area of this figure, what you can do, first of all, there are two parts in this figure, or you can say this is a combination of two figures. So first of all, I have to find the area of this triangle, and then after that I have to find the area of this portion of a circle, not the complete circle, because this portion of this circle has already been calculated in the triangle. So the area of this portion has already been calculated in this triangle, so only I have to find out the area of this portion. And if you look at this figure closely, this is the circle and this is this portion. This is this portion. Now this has already been calculated, so only I have to find the area of this portion, and obviously this is the major sector, which is the portion of a circle divided by the radiuses. Okay, radii, sorry. So here these two radii divide the circle into two sectors. This is minor, this is major, and I have to find the area of major sector. And area of triangle when added to the area of major sector will give me the area of complete figure. Okay, this is important. Okay, here area of shaded region will be equals to area of equilateral triangle plus area of major sector. Okay, now area of equilateral triangle is √3/4 a square, where a is the side of this triangle which is given to us as 12 cm. The side of this equilateral triangle is given to us as 12 cm. Now I have to find the area of the major sector. Obviously I have to use the same formula which we use to find out the area of a sector, which is theta by 360 pi r square. Radius will be the radius for the circle, which is this, given to us as 6 cm, but only difference will be of theta. In the minor sector we consider this theta, but in the major sector we will consider this theta. And because this is a equilateral triangle, so all three angles of an equilateral triangle are of 60 degrees. That means in a point the complete circle, or you can say the complete angle, is of 360 degrees, out of which this is 60 degree. That means the remaining will be 300 degrees. The remaining angle will be of 300 degrees. So this will be the only difference here. So theta by √3/4. My side is 12 multiplied by 12. That plus here the theta is 300/360 into 22/7 into radius, which is 6 into 6. Okay. Now solving this for 3 times 12, so it will be 12 into 3, 36√3. So this will be, when this is solved, now this can be solved further. 6 times, and 6 can be cancelled with this 6. and nothing can be solved further. So 22 multiplied by 300 is 660 upon 7. So this should be my area of this. The dimensions are in centimeters, so the area should be in centimeter square. If you want to solve this further, if you know the value of root 3, you can substitute the value of root 3, which is 1.732 multiplied by 36. Then you can minus this, you can divide this, and adding these two values will give me the area of this shaded region. Okay, so this is how you can solve this question. I hope you have understood this one. If you like this video, please subscribe to our channel. And if you have any problem in maths, you can directly contact us. This is our phone number, flashing it right here. You can call us or you can send us your query on WhatsApp. Thank you.